debugging the character plane generation board with the logic port 34 channel logic analyzer. I've connected one of the internal RAMs which deals the character bit plane data. So this is one RAM, the other RAM wasn't populated underneath there, and then this is the third RAM here. This unpopulated RAM here basically returns back a screen containing character 3FF and its related color. So I'm just making sure that when I set the memory bus and data appropriately here, and then when I tell the extended memory bus here to choose the bit plane character RAM memory here, then I make sure that the memory that I set here can be written to these RAMs here on demand, which it certainly seems to be. Now this is the character generation board tested in isolation. It remains to be seen whether or not this all works when it's all plugged together. But so far, according to the logic analyzer, the memory write seems to happen as expected. And then when I don't set the extended memory bus address here, then of course the expected writes don't go through to the RAMs, and then the character generation board switches to read mode for these. So then it starts getting different addresses depending on the character, and depending on the character lookup from here, and then from the screen data, and also depending on the horizontal or vertical, if you like, pixel position as well, because then it reads the next byte in the memory. But all of the internal memory bus calculations so far seem to be correct, so that's a good sign. It took a little while to connect up this memory chip with all of these little debug clips, of course, because it's quite fiddly work. Don't want to have to do that so often. This also here was testing the SL1 input as well, so just making sure that the logic, which takes the horizontal and vertical pixel positions and then generates the relevant load signals, was actually happening. So I had to basically fake a couple of coordinates here for the horizontal and vertical pixel positional values, if you like. And then down here as well, this is underscore CMP BLK, if I remember correctly. These ones were all set up by referring to all of this debug information here for the headers. So far the board seems to be behaving correctly. This little thing over here on the right hand side is annoying. I really wish I didn't have to have that. I may look at creating some kind of cradle for that, or some kind of like really hacked together header and making it a little bit more permanent. But so far everything's okay. So we can see that I've set up the logic analyzer software here to basically reflect the correct pin naming convention that I have. So A0 to A12 is set up here, and then D0 to D7. D0 to D7 is actually the data coming to or going to or coming from. D0 to D7 is actually the data coming to or going from the RAM. In this case, the RAM is in output enable mode because there is no write enable, and also the extended memory bus is not set. So if I set the extended memory bus to be high, then this basically starts to activate the necessary RAMs, and then if I do that, we can see here that the input memory address is high. What I've got in bit 0, say 0, I've got to set that to low too. So what I want to see is that when I activate the external memory bus, okay, so at the moment it's accessing memory at well, low, 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 and the rest of them are high. Whatever that is in hex, I'm not going to work that way out as quickly as I should. 1 FF8, if I remember correctly. So yeah, 1 FF8. Yes, I think so. Yes. 1 FF8. So then what I do is that if I set the corresponding extended memory bus bit to be high, which is going to be that one there, then what I would expect to see is that I want the same memory address to be presented, because I'm now switching from the internal to the external. So there we go, it's the same now. So then because it now switches in, because it now disables the output enable, it's gone high, you see, but there's no write enable yet until I set the write enable down to be low. And then if I set the write enable down to be low, then I can see that I'm writing, or the memory bus going now into the RAM, because it's write enable low. The pattern is high, 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 low, high, 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 high. That's kind of like 1 pixel in bitplane data being activated there. So then I set it back to be not write enable mode. Okay, like that. Okay, and then the data bus goes into transient or like high impedance state, I think. Because there's no output enabled. Then I go back to the memory address, and you can see here that now the output enable mode is now switched back on again. The logic for the character generation plane is now reading from the memory, low, 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 high, high, so 1 FF8 again. And basically what that means then is that it's showing, it's proving that the memory address down here has the memory address. It's proving that the memory address has been written to in the RAM, and now when it reads it back again, it's okay. But if I then change, say for example, the horizontal coordinate, I think the horizontal coordinate now is high, low, low, low. We can see here that the memory address contains whatever was in the memory at that particular point in time. The memory doesn't get a default. It doesn't have a default. Of course, it's kind of like random data each time, random-ish, noisy data, slightly noisy. And then so if I go back and want to write it again, then I can write another value like that. Write enable, no write enable, disable the extended memory again. And then this time I'm reading high, low, low, high, which is 1 FF9. Now, because I was writing to 1 FF8, then of course we're not going to see anything. So what I have to do is that if I want to do that, I have to basically set the memory address to be 1 FF9 on my external memory bus, of course. Thus proving, of course, that I wasn't writing to the wrong memory address, which is a good test in itself. So now I set the extended memory bus to be high. I do a write enable. Again, high, low, high, or 1 FF9 this time. Good. Write enable disabled, and then disable the memory bus, the extended memory bus again. And now, of course, it's come back to output enable mode, and with 1 FF9, and the internal memory address is high, 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 low, high, 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 which is the memory that we had just written using the second, 1 FF9 memory address. So that kind of like proves that our memory for that bit plane RAM anyway is working correctly and working as expected, and all of the bus logic is working as expected so far, which is really good news. So a little bit of a progress update. I've disconnected both boards. I'm not connecting them via these pins and headers anymore because I want to probe around a little bit more. I'm waiting for the correct size memory for the character generation boards to arrive. So one of the character bit plane RAMs was forgotten, so that one's arriving in a couple of days, and also a narrower a wider form RAM to fit inside the wider form socket here. I've already updated the next version of the PCBs to use the narrower form of the RAM, which seems to be a lot easier to buy. The wider form of the RAM, currently via Mouser, was a little bit harder to purchase. It needed some kind of export form to be filled in. Anyway, so that's on its way now. Now that I've attested that I'm not wanted as a criminal in the United States and I'm not going to use it for military purposes, etc., etc. So when I was experimenting with this kind of open reverse upside down board arrangement last night and early this morning, I found that the design when it's like this, with wires or quite long wires bridging the gap here, was quite unstable. So the video conversion box here was showing that the video signal was oscillating quite a bit. The timing of the signal was like sometimes it would go down to 57 or something like that hertz, and sometimes it would pop up to about 73. So it was varying a bit, and I noticed that especially when I was touching the wires here. Now these wires correspond to the, admittedly they're quite high frequency, the row column header here. When I was touching these wires, or when I would wave my hand nearby, the signal here on the screen was getting quite unstable. It was blanking out. Sometimes the video generation board, video conversion box would actually lose the signal entirely. It was a little bit ill, and I was thinking about that today, and I was thinking maybe with the screen being so close to wires which were admittedly quite a lot longer than this, basically I took one of these wires plus one of these, and I bolted them together and then used that, and it was not very good. I think I was getting some RF interference, or maybe some signal reflections, and due to the joints being quite bad and quite freely floating. So this evening I decided to rewire the whole open board concept just using short wires here and here, and it seems to be a lot more stable now. I can actually see a nice stable picture. I've just conducted a quick character bitplane RAM writing test to check, and there's a result that actually one row of the same character is all the same bit. It's that kind of like reddy browny color, which is good, because previously when it powered on, it was a bit pattern. So that's okay. So that actually means that test for addressing the RAM on the character generation board is actually working properly now, and it's writing in a stable manner and in a stable expected manner. So the reason why I was taking this board apart as well is that I have actually found in my bits box a whole bunch of spare 34-way ribbon cable and these lovely plugs here. Now these plugs actually fantastically they would fit on the pins for these headers. So I made up a couple of these cables, ding ding, and this one too. And I connected both boards up with these cables, and I found that I wasn't getting any video signal at all. So I was, troubleshooting the cable. I was, troubleshooting this and that. So I decided to use the longer wires connection to just connect up the boards, and that's when I discovered that it was a little bit unstable. It may also be due to the fact that for these headers here, and well, on all of the headers, I was relying on floating to give me logic high, and I don't think maybe that's a terribly good idea, especially when connecting two of these boards together and using wires and stuff. I think that it was probably the floating high was maybe not always completely reliable. So I decided that for all of the important signals where it needs to be definitely low or definitely high, for the low ones it's obviously connected to the board, but also now for the high ones, so memory enable right, which is this one, and like this one here, have now been explicitly set to be high. I definitely do not want any spurious memory writes to be happening. Likewise for the extended memory bus lines, I've tied them definitely low. I've not left them floating or anything like that. Also, for these signals here, as it's appropriate, I've tied underscore, display enable to be low and display enable to definitely be high. Okay, so none of these are going to be floating anymore. We're not going to be introducing any spurious lows when they should be definitely hard highs. So it seems to be a lot more stable now. I can touch these wires, I can wiggle them around. The signal is perfectly stable. So that's good. That means that this configuration works. It now means that what I'm going to do is that I'm going to try one of these cables in this header here, and I'm going to see if I can remove all of the need for all of these wires here. I'm going to see if that's a lot more stable first. So let's see. So slight progress. I've removed all of these wires pretty much and replaced it with this, actually a relatively long ribbon cable. It's this one here. I'm going to put a little tick on it later on, indicating the position on the plugs rather, that I'm using. So actually by convention there's this little red line along one edge here, so I'm using this side to sync up with this header here. This is the video 1 header. You can see all of the signals that go into this. So what I'm actually doing is that this long wire here is tying low. I think it's the border Y, yeah, because I can see now that I've got a taller picture, which is exactly as I'd expect. Now, I noticed an interesting effect on the screen as I was connecting up this border Y, is that it was producing some flickering, alternating vertical lines as I was connecting it up. And I think this is really a good indicator about the kind of electrical interference that these longer wires are picking up as I touch the wire. So if I disconnect it, and I started to disconnect it here, and I was touching the pin on the end with my finger, so I'm just doing this, boink, boink, boink. And the strange thing is that I am actually feeling a little bit of a current, and I should not be feeling a little bit of a current. Maybe it's my imagination, but I can see if I hold it down, it's actually, yes it is, there's definitely some kind of current there. Now this is really, really intriguing, because if I work this out, I can probably work out the timing of seeing these very slight vertical strips. They're sub-pixel accurate, so it's tiny little pixels appear. Now, I am grounded, as you would expect, right, with this little plug thingy here. It's meant to have a common ground all the way through here, all the way through here. Right, the video box is on the same strip plug. Everything should be fine. So I am wondering, right, as I'm connecting this up, this would explain why when I was connecting it up, I would see the display sometimes. Yeah, I was connecting up these wires with everything live, so I could actually see the progress. I wanted to check every time I was plugging in a wire. I wanted to check that the video signal was good, still good. It wasn't alternating around all over the place. But basically, this indicates the kind of interference that I'm picking up through sometimes through a wire. So what I did then was that I was going to the border X, and you can see here that the border X is even more sensitive. So I don't even have to be touching the pin on the end of this wire I can just hold it by the insulation, either here or further down at this point here. If I'm just holding it on the insulation, I'm getting this very straight, this is the border X line. Right? If I'm not tying it specifically low or high, then I'm getting this weird effect here on the side of the screen. Don't know if you can see that. It's tweaking very, very slightly by about a pixel, which is really interesting. So if I leave it alone, dangling, most of the interference goes away. But if I then grab hold of the insulation, it's come back again. So yeah, this gives a good indication that this circuit is especially sensitive with these long wires to potentially what looks like RF interference or some kind of other analog electrical effect, which, I'm not an analog electrical engineer. I designed this PCB using my best effort, but relatively long wires, relatively long connections, which are a little bit unreliable. All of these edge connector pins, right, are long and hanging deliberately so I can connect stuff to them, but they also potentially cause things like signal reflections, and they would act as little mini antennas as well. So I'm not surprised that I'm seeing this. This is what we get when we're developing, through-hole component PCBs. I guess this is why surface mount components were invented, because they're less susceptible to kind of like interference. They don't have legs which will act as signal reflectors and all sorts of other weird analog effects. So you can expect that, because electrons are rushing around at relatively high frequencies. The clock for this is around about 12 megahertz, and internally the board is clocking around at 6 megahertz everywhere. So I'm not overly surprised, but I'm just really intrigued that these kind of like length of wires are generating this. So there we go. I've tied the border low, border X low now, definitely, and I'm going to tie the border Y low. Can I connect this with one hand? Maybe, potentially. I've noticed that these wires here, the join is not that great. For some of them, there's a little bit of inconsistency probably between the manufacturing process. So there we go. I've tied both of these wires low now. So now if I grab the insulation, there's little indication of any interference. Actually, the screen is nice and rock steady, even with this huge, great big ribbon cable here, which is great. That's really good news. That's fine. And here too, likewise, it looks good. So what I'm going to do now is that I'm going to do the same for the extended memory bus header, which is this one here. Oops, this one here. This one here, and also the row column header, which is this longer one here. The row column header is the one that when I was connecting out with the long wires was especially dodgy, so it was unreliable. So the row column header here, as you can see, has 1H, 2H, 4H, or the horizontal and the vertical screen pixel counters, all exposed via this header. The vertical stuff is not changing that often. The horizontal stuff is changing every 6 megahertz. Right. So it's relatively, in inverted commas, high frequency for a thrown together auto place, pretty much an auto routed PCB. The only parts that are not auto placed on this PCB, on these PCBs, are the output circuitry here with the resistor ladders and the common headers here and the pixel headers. Those were placed by me, obviously, because I want to make sure that they're in consistent places, but all of the other components pretty much were auto placed. Oh, the clock timing as well was explicitly set out by me as well, as best as I could with my limited, almost non-existent analog electrical engineering knowledge. But the rest of the PCB, all of this stuff in here was automatically placed and automatically routed. So I'm not overly surprised that I'm seeing these kind of analog electrical effects coming into play as the board was like this. Now, when I had the pins here going into the sockets here, into the headers here directly, I didn't really notice these kind of effects. I'm not surprised, because having these pins, the pins underneath the video board go into the sockets of the character generation board. Yes, the character generation board is on the bottom. That was a rock solid, very solid connection. It actually took a lot of effort to disconnect them again. That's why I don't really want to put this board back together again underneath here using those pins. I think it was far too troublesome. That's why I was experimenting with using ribbon cables and connectors. And I think the next version, if it's all stable, I think the next version will use connectors and sockets a bit like this, probably even a little bit more beefier. Oops, that's not focusing terribly well, is it? Probably sockets like this, because they're a lot easier and more stable, and they are a lot easier to disconnect and experiment with. So I'm just experimenting really to see if a 34-way cable can cope with interfacing all of these complex signals without any noise. So anyway, progress. Now I'm going to progress on and see if I can reconnect these with a ribbon cable, and we'll see what happens. Wish me luck. Okay, just a supplementary note. As I was saying, wish me luck, and stopping the recording on the phone, the screen blanked out and then came back on again with this different RAM pattern. Oh, there we go, it's done it again. I think I know what this is. I think it is the voltage regulator overheating. I think it's getting rather hot because it has been on for quite some time. So that might also have something to do with it. When the voltage cutting off like that is very indicative, and the RAM pattern changing is very indicative of the voltage just dropping far too low, because the voltage regulator is getting far too hot. I really do need to invest in a better voltage regulator. Now I also moved over from the voltage regulator from this board to using this apparently more beefy voltage regulator. It's meant to go up to about 2.5 amps, I think. Whereas this one I think was regulated for 1, maybe 1.5. But even then it's still struggling. It's having to dissipate a lot of heat through the heatsink. That's why I bolted on the heatsink, tied on a heatsink. But I think we're getting some kind of overheat effect as well coming into play here. So I'm going to let it cool down as well while I disconnect all of these wires and connect up the header, and we'll see if it's still stable. Okay. So, small little status update. As you can see, I've disconnected all of the wires here, and likewise here. I have not connected the other end. This is just the video generation board on its own. This is to basically check that there are no shorts on the cable or anything else wrong with the socket, because I had to make these by hand, and I crimped them together with pliers because they require quite a lot of force to put together. And this is just to make sure that the socket as well and the pins and everything underneath are all good. I can wiggle it around, I can touch it around, and I'm not seeing any difference in the output video timing. It's 59.66 and 264p, which is perfect. What I am seeing on the screen, interestingly, is because this one, the video header, the video 1 header is all connected up. So all of the timing signals and everything are all okay. But the horizontal and vertical pixel position is not. It's all floating high from the character board. So what I'm seeing here is the effect of basically fetching the same pixel from this all the way down the vertical position of the character. So obviously the addressing is not going to work, because the addressing for where to fetch the pixel from in the bit plane RAMs comes from, and also the character screen, which is not connected, so it's floating high already. So the addressing for that comes from the information here. So that's why we're seeing the same pixel being fetched over and over again, but that's a good sign. It means that there's nothing wrong with this socket here, and there's nothing wrong with the cable per se. Plug. There's nothing wrong with the plug, there's nothing wrong with the socket. So I'm now going to connect up this one to see what we get on the screen, and to see where the instability that I was looking at yesterday, where it would come from, right? We're just connecting up. We are removing wires and we're connecting up with ribbon cables. In theory, it should work. So let's see. Another short update. This is kind of like just like a build log, really, or a debugging test log, really. That's what it's turning into. So I've almost pressed down this cable here, and I've made sure that the pins are all round. The pins are located properly. I'm just about to press it down. So the video signal is stable, but now when I start to engage some of the pins further up the header, so when I start to engage, so at the moment I think 1V and 1H and maybe 2H and 4H are engaged, because I'm starting to see the pixel rows come in for the character. When I start pushing it down further, I start seeing more characters. But then when I start, I think, engaging the higher video, it switches off the display. So I think what that means is that somewhere up the cable, or somewhere up the header, so I was engaging these ones first down at the bottom, and as I was applying more pressure onto the plug, the connection would gradually creep up to here. And I really do. I think there's something. So this one and this one and this one all seem to be okay, because I was seeing a full character. Okay, and then this is because the characters are 8 pixels high, right? Because the characters are 8 pixels high, I was seeing this is the vertical side, obviously. So I was seeing 1, 2, 4. 1, 2, 4, all added up together gives 7. So values from 0 to 7 for the vertical pixel position was okay. But so I was seeing full characters, but then somewhere here, maybe 8, 16, or 32 bits, it was really going wrong, and maybe 64, 128. Maybe it was this side. I'm not entirely sure if it's the vertical or horizontal position which is making the display flick out, but I was definitely seeing that, and it was definitely kind of reproducible. I would lift it back up again and the display would come back again. I was also seeing the display fluctuate wildly, like I was seeing when I was connecting it with the long wires. So that's going to be interesting. So what do I try? Now, those of you who do this kind of digital analog electronics work will be screaming now at your screens, at your YouTube screens, basically saying, "You great big numpty! All you've got here is that you've got a broken cable, or you've got a broken plug." I know pretty sure that these pins here are okay, because I can connect back the wires and everything was fine. Or you're going to be saying, "Oh, you numpty, you've got the plug here is wrong and it's connected to the cable wrong, or that there's some kind of like short between it." And you're entirely correct. Almost certainly I am a numpty, because as I say, I'm not into analog electronics. I don't know an awful lot about analog electronics, to be honest. I just know enough to cobble boards together like this. So this is going to be some interesting debugging. But it's heartening that when these boards were sandwiched together, as before, we weren't seeing any of this with these pins underneath going into this header on the other side of the board. It was all fine. So I'm pretty sure it's just me being a numpty. Maybe I can try the other end of the socket. Instead of this end, I might switch it all over and turn it over and then just try that, and we'll see what that does. Basically use line 1, right? Conventionally, this is the first. So we'll try that. And if that doesn't work, then what I'll do is that I might try using this really, really short one, by ripping off one of the plugs and then bunging it on here. It might be the fact that I've ripped off one of these plugs before and I damaged it somehow. Or I'll carefully examine it with the magnifying glass and we'll see what happens. But reproducibility of bugs means that I'm almost there in being able to find the issue, which is great. Debugging log update. So I've disconnected the ribbon cable, I've flipped it over, so now I'm using the other end of the plug in the same socket. I have not connected the other side as before, and hey presto, I'm seeing the same effect as we saw before, which was explained by not having the vertical position lines connected up. So progress, more debugging. Just before I forget, things of note. So there is an electrical storm going on at the moment outside. I can hear the thunder rumbling away, and the rain is quite heavy. So maybe I'll be getting some more interesting effects, and this might complicate the debugging slightly. But hey, with these long wires here, they may be acting as an aerial for nearby electrical lightning strikes. But we'll see what happens. So debugging progress update. This plug is not entirely seated on the header yet, and we can see that we're starting to see a repeated row of, I think that looks like 4 pixels, which means that the first 2 vertical lines on the row and column headers are connected. If I apply a little bit more pressure, we might, the display has already blanked out when I put too much pressure on. If I put a little bit more pressure on, okay, that really is intriguing. So it might be something towards the top end of the header. It might be more than one wire. It might be the fact that it's a very long cable, and we're getting some unintended effects. I'm not entirely sure how to debug this cable further, apart from getting the multimeter out and testing individual connectivity for all of the wires and to make sure that there's no shorts. But it looks like there may be an issue somewhere near the middle of the plug on a range of pins. Bother, more debugging needed. So debugging status update. another one. So this was the cable that I was having problems with, and I yanked the plug off this. Yanked the plug off this end. As you can see, I don't see any damage. If I zoom in, and maybe if the autofocus would pick it up, I don't. Apart from the connections and the holes for the blades in the pins, I don't see any other damage to the cable. I see all good connections here. I've looked at it under the microscope. I don't see. Well, I don't. Yeah, right. Zooming right in, you can't see any. So that was the cable. I have put it in here. So shorter cable, because I was using that new other cable which had one plug on the end already. I put the plug on the other end, so I put the plug here. I haven't even added the strain. I think this is what's called the strain relief on it or anything like that. This thing here, because I want to test it quickly. So I've not seated this end down onto the header properly yet. That's why we're seeing this expected debug pattern here, which is entirely expected. So I'm going to start pushing down on the lower bits 1V end. Let's see what happens. So I start pushing down with my thumb, and there we go. I start seeing progressively more pixel positions on the characters. That all looks good. I'm going to push it all the way down, and it's perfectly fine. So I'm pretty sure that all of the pixel position pins now are connected, because I've nearly engaged the socket properly on the header, and there's no problem. So that tells me that something wrong with this cable. Was it this end? Was it this end? I don't know. The only way, if I could really tell, is, or is it the length of the cable? Oh gosh, this is something that's gonna. Did you hear the thunder? I did. This is a thought which is going to fester now, isn't it? I'm going to need to do a little bit more testing for knowledge sake on whether or not it was the length of the cable, or something damaged in this cable, because this is like this other one actually, but this was a really old cable. You can see that there's some discoloration here. Maybe something got kinked in the middle, I don't know. So what I could do is that I could take the plug back off this end, because I know that this is working. I could take the plug off this end and then put it back on here. Do I want to do that? I mean, I've got a working cable here. Yes, I should. I should really. Yeah, I'm gonna, because otherwise I'm gonna have an unknown piece of knowledge that I really do need to figure out. Okay, that's what I'm going to do. Very short debugging status update. I made sure that this plug was all the way down on the header and engaged properly. Perfectly stable screen, no problem at all. Okay, so debugging status update. Instead of resurrecting this cable, which I ripped the plug off one end, because I had a long and a short cable, I decided to do this instead. So the video header, which is down here, is now connected with the short cable, and we're seeing expected pattern on the screen as the same pixel position is addressed over and over again. I've connected the long cable to the pins underneath here, and I'm just about to start connecting the plug on this header here. So if I start pushing down on this end, hello autofocus, right, if I start pushing down on this end, we start seeing bing, 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 bing. Oh, there we go. Oh, the video signal has flipped out already, but I think that's because I'm engaging some of the pixels on the far end. If I lift it up slightly, there we go. So what does this tell us? Well, it tells us that for the high, maddeningly enough, for the higher frequency pixel positions, horizontally or vertically, it seems that the lower portions, so the signals towards the low end with the long cable, it's the cable length. So we can see here that I'm starting to get a repeating pattern of 4 pixels again, as expected. I engage more lines and I get more character positions, and then the screen flips out. So it looks like it's entirely down to cable length. This is worthy of note. So basically, this tells me that I'm seeing some really strange signal crosstalk issues, potentially, with a long cable. Whereas with the short cable, it was all fine and perfect. Wow, I was not expecting anything like that at all. So the frequency ranges are quite wide and varying. This is 6 megahertz. 1H changes at 6 megahertz rate, and then it divides down as you would expect. The vertical position, is nowhere near 6 megahertz, right? It's much less. So, funnily enough, I think the vertical position is updating at 15.74 kilohertz, right? I think that's the line length, if I remember rightly. Is that the line length? Something like that. So anyway, this side doesn't have very high frequency, relatively speaking. This side has the high frequency in there. So the high frequency pins, right? Engaging these and engaging these up to about here doesn't matter. But then when something across here engages, it just goes completely bonkers with a long cable. If I switch it back now so that the short cable is on the row column and then the long cable is on here, this tells me that maybe I should be a lot more economical with my cables between these boards. That's definitely worthy of note. Definitely worthy of note. It's a very important piece of information when I'm looking to expand these boards further and I need to consider crosstalk considerations for this row column header. It may also mean that I may want to completely separate this header out, have it on a different place on the board to isolate these signals even further. Interesting. Really good piece of information to know. Okay, I'm going to leave it there. I'm going to put back the cables. So I'm going to have this short cable now on these ones here, and I'm going to have the long cable here on here. I might chop this cable and make it shorter. Who knows? We'll see how that goes. Anyway, but cool. And it's getting late now. It's nearly midnight. So I might just knock it on the head there and go to sleep safe in the knowledge that I've acquired some more knowledge and stored it in my brain, which is fantastic. I always love learning new things. So I think this is going to be the last debugging status update now for the evening. I've put back the nice long cable on these headers here. The short cable is now not just across the row column header here, but actually the plug is across both the row column header and also the extended data bus header here, so the pins extend down here, of course. Likewise, for the bottom of this board, character generation board, the pins for the extended data bus header were coming up here, and then the row column header were here. So I've used this 34-way connector to bridge both of these. Luckily enough, the headers were separated by the correct amount. Well, the PCB layout tool helped me there because the grid was set correctly. Happy accident, which is always nice. So the plug is now seated properly on pins. It's pushed pretty much all the way down. The pins underneath are seated properly inside the plug here. It's pushed all the way down, and we're getting a lovely, stable picture. Fantastic. What this means, of course, is that now when I change this is all forced to be low, and this one here corresponds to, if I find the expansion bus debug information, that top left one, down one, so pin 6 on the header is EBS5. EBS5 is the high nibble, so 1, 2, 4, 8, it's 2, 0. This is 1, 2, 4, 8, but it counts up, and this is the low nibble, this is the high nibble. So it's 2, 0, and 2, 0 corresponds to the debug information, how the board was set up in the PCB layout tool to be extended memory bus address 20, which basically addresses all of the RAM for the character bit planes on this board. The character screen data comes from EBS 0, so that's 0, 1 in hex, not 20 like it is from up here. And 0, 1 basically addresses all of the original RAMs that were visible then via this in-RAM cell here. So the screen and character color, so the character screen and the color memory address into here. For the RAM that was meant to be wide, but ended up being narrow. So that's the one that I've reordered. So that I've reordered the wide one. So everything is perfect now. Everything seems to be working. It does tell me that I should really order some more of these. I shouldn't really waste a 34-way on this. I think it's 20-way. It's 10 and 10, so yeah, it's 20-way. This is 17 and 17, which is 34-way. Yes, good. I should have a 34-way for this one here. So, and this is a happy accident, very happy accident, 34-way across here. So that's fine. So, but these kind of like long board interconnects, I'm going to make shorter. This cable works. I'm not going to destroy it. So I'm just going to order a whole bunch of new IDCs like this. I've actually got a bunch coming in from the US, and we'll see how those fare as well. If they sit nicely on the pins, which I'm hoping that they will, then I'll use those. If not, then I'll order more of these, because these ones are actually really easy to put together, relatively speaking. They're not as painful as these ones. So I had these ones floating around too, and these ones are vicious. They've got horrible sharp little pins on top, and then they've got these things here, and they're very narrow, and they flip and everything. I don't like those ones at all. I tried to put this one together. No. This style. These ones were ordered many years ago, and I'm very happy that I still got them. But it's this style here, and because there's no pins on the other side, because they're just plugs, they're very easy to squeeze together and to grip with pliers. These ones are horrible. They really are terrible. I really did not like trying to put those together at all. They really hurt my fingers because they're not easy to grip at all. So I'm not going to be ordering these. And the plugs really work well on the pins anyway. And the reason why I like these long pins is that I can, as a debug thing, I can poke my debug connectors in the top sockets here, right, in these headers here, but have the board interconnects all connected up via the pins underneath, which is, for debugging purposes, when I debug this board in isolation or debug this board in isolation and connect it up to the logic analyzer, it's great. It's very comfortable. So I like this arrangement. as I say, I'm just going to make this cable a lot shorter, and then I will have another 34-way interconnect here as well, just for the memory bus. The 34-way expansion memory bus looks like this, right? This was for the debug. This was for the 6502, 6510, like TTL project I was doing, and the memory bus seems to work really quite well. It's got the various lines on it which let me do all of the various things that I want to do in terms of having bus direction and, you know, basically telling it whether or not it's tri-stated properly and things like that. So this seems perfectly adequate. And it means then what I can do is that I can feed in the information from the C64 Commodore 64 user port into this top header here. Like I can do here, I can feed in the information now into these top headers. Especially when I get this interconnect done, but this interconnect with the extended memory bus allows me to feed in the information here, and then I can test everything properly in situ, which is fantastic. So I'm really happy. Very, very nice progress. Learned something new today about ribbon cable length, and also cable length for all of these things. Yeah, fantastic. Really, really happy, really productive day today. I'm really happy with how that's turned out. I cannot wait to get the RAM for this arriving and to feed in the extra bit plane. When that happens, what I can do now is that, because I've got a whole bunch of spare cables, a ton of them, what I can do is that I can hook up some more extensive memory debug patterns. I can start programming in, you know, characters, screens and stuff like that. Really good. This is really, really fantastic. I'm really looking forward to tomorrow, when it's not so late, when I can play with this again and learn more about this fascinating subject. So yeah, you know, if you are watching this and you're telling me, screaming at the screen probably, you know, you great big numpty, you should really be thinking about, you know, crosstalk a lot better and isolating your return paths, you know, having proper return paths and having, you know, nice beefy power sources. And you should be looking at, you know, reducing signal reflections and stuff. Please do comment in whatever video this turns out to be in. Please do comment and you know, for the benefit of everyone, you know, as a learning experience, please do share your knowledge if you are able to. I would really love to learn more about this, because this is not going to stop at this character board. There is a sprite board. There is a 16 by 16 pixel tiles board. There is the huge, you know, ginormously large, in comparison, Mode 7 board, which I want to try and get working. You know, I think what I'm going to have to do is that I'm going to have to start thinking about much beefier power for this, right? In theory. And you know, these are 6-layer boards, and I've put links to the Gerber files, the Proteus files and everything else, so it's all open source, so everyone can see exactly what is there, how the layers were stacked up. You know, I'm really quite happy that it's working to this extent. I know from when I've been doing some reading on this, I get some kind of feeling about how difficult, you know, analog interactions in digital electronics can be, especially at relatively higher frequencies. And you know, 12 megahertz is not that fantastically fast, obviously, for modern electronics, but for through-hole, you know, soldered up components, 12 megahertz is maybe starting to get into the range where we really need to do, or I need to start really thinking about proper, you know, power, plane separation, return paths, location of headers. I've put them on the edge of the board because it's easier for access. And I was just reading something today about a happy accident that putting headers on the edge of the board is really good because it helps to separate out your signals. So yeah, please do, if you've got any knowledge about this, please do put it in the comments. Please do send me you know, a private message or email or whatever to help me gain more knowledge in this area. I'm always happy to learn more. from people who have really good experience in this regard. So yeah, thank you for watching up to this point. So when the components arrive, I'm going to populate this board with more RAM. I'm then going to start displaying very nice, prettier pictures on this rather than debug. Debug. Well, no, it's not debug. It's whatever values were in the RAM at power on time, right? But yeah, excellent, lovely, really pleased, chuffed to bits with this so far. All right, good night.